Right. But you told Mikey if I don't have those line segments in by 3 o'clock tomorrow, there's going to be some problems here. We got to get these things built for tomorrow. Oh, I got to let you go. Hang on. Sorry. Bye. Sorry, guys. Just taking care of a little bit of business here. So, yeah, I'm a teacher, and as teachers, we wear lots of hats, as you can see. And one of my many talents, besides being an excellent teacher, is that I'm a detective as well, and a couple other things. But I'm also a bit of a builder, right? And a mathematical builder, if you will. I build a lot of shapes mainly, and it's a busy time of year. People order in a lot of shapes, and I'm trying to balance that and the whole teaching thing and all that kind of stuff. So let me put some of my tools down here. Just trying to keep everything organized here. But I'm actually glad you're here because I got some orders coming in for some more shapes that I need to build in. I know you guys have been previously learning about shapes and angles and all sorts of stuff, and particularly triangles. So I was hoping maybe you guys can help me with some of these triangles I got to build today. We can maybe work together. We can get these things jammed out. I got guys breathing down my neck looking for different stuff. So let's do that. Why don't you guys gather up some supplies? I got some tools here that I'm going to use. You guys are going to need maybe some of the same things. If you got something to write on, something to write with, that's going to be great. I have a protractor here and also a ruler, which are going to come in really, really handy. And I do have some of my definitions here of what different triangles are. So like my equilateral triangle, my isosceles triangle, my scalene triangle. I want to have that handy as well because I'm probably going to need to refer to that as we go through. So gather up some of these things if you need them, if you have them handy. And I can definitely use your guys' help building some of these things out. So let's get our hands dirty. Let's start making some triangles. Go ahead and pause, grab what you need, and when you're ready, click play, and we'll keep going. Man, never a dull moment here at Mr. Walker's construction company here, and it looks like I have an order coming in already. So let's take a look at this one. This order is telling me they need a right isosceles triangle, a right isosceles triangle. Now, if we think back into our memory banks a little bit here, I know a right triangle is going to have a right angle in it, right? So I know I'm going to have a 90-degree right angle in this triangle somewhere. But it also needs to be isosceles. And if we look up here at our definitions, isosceles triangle has at least two sides with the same length. Two sides have to have the same length. So I'm going to start by grabbing my protractor here, maybe make it a little bit smaller. And I'm going to start by drawing the right side of this, right angle. So I'll put one line here across the bottom. All right, and I'll measure up my end point there, and I'm going to draw this at 90 degrees. So there's my right angle. There's the first part of my triangle. Okay, so I have that good there. And then it says they want an isosceles one, so at least two of the sides have to have the same length. So I'm going to grab my ruler here, and I'm going to measure this out. And let's say I'm going to go ahead and extend this line out to the 3 here. So I know that this is 3 inches on this side. Then I'm going to move my ruler over here and make sure that this side is also 3. Let's see, line this up here, extend this out. So this one is 3. So these two lines are 3. And then I'm just going to take my ruler and line it up here. Hopefully you guys can see that okay. And I'm going to use that to draw my third line here for my triangle. 3 lines, right? So I have my triangle. These two sides are the same length. They both measure 3 inches. 3 inches there. So that makes it an isosceles triangle. It also has a 90-degree angle here. So it is a right isosceles triangle. So our first customer is going to be happy. We made a triangle for him. And you guys can see my new trainees here from my construction company. You can see how I used my protractor first to get the angle I needed, and then I used my ruler to help me draw the lines. I could have drawn lines first, but I have to make sure I had that 90-degree angle. That was kind of important. So that's why that protractor came in handy first. So that's good. All right, easy enough. Okay, back to the math lesson then. We can get into this. And hang on. Another order coming in. All right, let's take a look at this one real quick. This one, they say they need an obtuse and isosceles triangle. Obtuse and isosceles. So we know isosceles, again, two sides are going to have to be the same length, but this one just says obtuse, and they weren't specific about an angle, just that it was obtuse. So let me go ahead, we'll get this one out of the way, and we'll start constructing this new guy for our next customer. So an obtuse isosceles triangle. Well, the good thing about this is an obtuse angle, we know what an obtuse angle is, right? Obtuse angle is anything bigger than 90 degrees. So we can make our first angle whatever degree we want to, as long as it is greater than 90 degrees. So if I start with my first line here, all right, my straight line here, and then I have my 90-degree mark, so I can draw an angle anywhere in here. Or if I wanted to, if I had my 360-degree protractor, I could even go to the other side. I can make this a really big thing. Now, if you go too big, though, if I go out here, I can't really like connect the triangle over this way. Like that's going to look kind of funny. So that's not going to work out too well. I could connect it underneath here and keep my obtuse angle that way. But basically, I'm not gonna be able to go like all the way around this. Okay, so we can kind of keep that in mind. So why don't you guys go ahead and pick an angle greater than 90 degrees. You could draw your triangle on your side of things. I'm going to sketch one out here, and then we'll kind of compare and see what we get. All right, so I went ahead and drew mine at 140 degrees. So I know that my angle is obtuse because it is 140 degrees, right? 140 degrees. So I'm able to do that. Because it's an isosceles obtuse triangle, I have to make sure again that at least two of my sides are the same length. Two of my sides have to be the same length. So let's measure this up here and see what we got. This one looks about like 2, almost to 3. So we'll say that that one's 3. I'm okay with that. I'll make it a little bit longer to make sure that it's 3. Again, I could have made it 2. I could have made it 4. I could have made it anything I wanted to. It just so happened to work out at 3. And look at that. That one's pretty good at 3 as well. So these two sides measure 3 inches. They match here with 3 inches. So I've met the criteria for an isosceles triangle. I've met the criteria for an obtuse angle. Now I just have to draw that third line in there to connect this to actually make this a triangle, right? All right, lined it up pretty close here. It's not going to be perfect on this, but there we go. There is my obtuse isosceles triangle. You can see how I was able to draw in. Now this line in the back here, this one is obviously longer than my other two, but that's okay because it still meets the criteria for an isosceles triangle because two of those sides are the same length. Whew, cruising right along here. All right, this is easy enough, right? So let's go. Oh man, another one. I can't. All right, guys, can you hang in there with me for one more? I got these orders. Man, they just keep coming in. Let's take a look at this one. This next order, as it says here, they want an acute scalene triangle. An acute scalene triangle. So we know an acute angle, a cute little angle, it's going to be smaller than 90 degrees, right? Smaller than 90 degrees. And it's scalene, so none of the sides can be the same length. None of them can match. So we got to be careful when we're drawing this one out. So I'm going to take my protractor over here, and I'm going to, you know what, guys? I'm kind of tired anyway. I'm kind of worn out. You guys jump in. See if you could draw a scalene triangle that's also acute, an acute scalene triangle. Give that a try, pause it, and then let me see what you got when we come back because I need a break. I got to go grab a coffee or something. All right. I see what you did out there. That's really good. I'm going to take a stab at it too. You guys can let me know how I do on this one. So I'm going to start by just drawing a line here. Okay, that's going to be my begin point. I know it needs to be acute, right? It's an acute scalene triangle, so I'm going to make it less than 90 degrees. I'm just going to come in here maybe to about the 40-degree range. 40-degree range right in there. Okay. And I was careful at first to make this line a little bit longer than this line because according to our scalene triangle definition, none of the sides can match. None of them can be the same length. So this one's longer than this guy, and then if I draw this third line in here, I could just check with my ruler to make sure that they're not all the same length. So that guy measures about 2. This one on the bottom here is about 3. And this one over here is a little bit less than 2. So my angles, or my
My distances are all different. This guy was 2 inches. This one was 3. And this one was like 1 3/4 inches. So all of my distances are different. My angles are also acute. So we've got this taken care of. This was a good one. This one worked out okay. All right. So I think we're starting to get the idea of how to construct this. I think you guys, I don't want to teach you too much. You're going to open your own triangle construction business and put me out of work. So let's go ahead and move on to something else for a minute here and see what else we could figure out. Oh, I'm getting another order. Oh man, looks like I made a mistake in one of these. They're asking me to take a look at my work here. Hang on, let me call this guy back and see what we got going. All right, so I had this customer send me this picture of this triangle that they ordered, and they said that they had ordered an isosceles triangle, and this is what we sent them. And I'm trying to look here, and it's isosceles triangles, at least two of the sides have to have the same length. So these guys don't match. So what would this length have to be in order to make this an isosceles triangle? What would, in order for me to be right and have sent them the right product, an isosceles triangle, what would this have to be? Right. It would either have to be 2.5 or it would have to be 4. So I'm gonna take my ruler here and move this up and uh-oh. I'm looking at like 4.5, maybe 5 on that length. So that definitely doesn't match my other two measurements. And he is not a happy customer, and he says he's on his way down here to help me straighten out my triangles. All right, guys. I gotta go. I appreciate your help with all of these triangles today. If anybody comes around asking about the Mr. Walker Construction Company, just tell them that they're on vacation right now, and we'll get back to them later. So I'm gonna run. You guys keep practicing with this. Keep building, because you might be having to open up your own construction company. Once mine goes out. So I'm gonna go. Thank you guys. Talk to you next time.